Hello, chemistry, Mr. McKee here, and today we're going to talk about predicting double displacement reactions. And this is actually going to be kind of a two-part process. We're just going to do the first part today, in which we focus on the mechanics of the displacement. So recall my dance analogy from earlier in the unit, and that with a double displacement reaction, we have two couples, A and B and C and D, arriving at the dance, and they are going to exchange dance partners so that A is going to end up dancing with D and C is going to end up dancing with B. The key thing, which I'll emphasize here in a minute again, is we always have to have a cation and an anion in these couples. We can never have two cations, or we can never have two anions. So here's the steps that we're going to follow. I won't walk you through, or rather, I won't read all those steps right now, but I am going to walk you through those in your examples. So please get an example sheet from me if you don't already have one. Here is our first example. We have barium fluoride reacting with sodium boride here, and we're going to predict the products. We're going to ignore the state of the matter right now. We're going to get into that in the next part of this lesson, and that's going to be really important eventually. But today we're just kind of focusing on the mechanics of the switch. So the way to make sure that you get the switch correctly is to think kind of systematically here. We're going to, in our recombinations, we're going to combine these outside ions. So we're going to have barium pairing up with boron. And we're going to combine these inside ions, and we're going to have sodium pairing up with fluoride. You'll notice I put arrows in there. That indicates which ion is going to be written first. We always want to write the cation first, and that's why I put sodium first there and fluoride second. Now, something I probably should have started off with here is we should have identified the charges of all these ions. So the charge of barium is +2, fluoride is -1, sodium is +1, and boride is -3. And that's going to be important on the other side when we get to step 2 here. All right, so I just completed step 1, which is I predicted the products. And we're always going to have a reaction in the case of these double displacement reactions. So we don't really have to, we don't consult the activity series to see if a reaction is going to happen. We just assume that the reaction is going to happen, and we're going to have an exchange of dance partners here. So step 2 is to neutralize the new ionic compound here, all right? So we look at our charges. We've got +2 for barium, and we've got -3 for boron, and we're going to do our crisscross. So the charge of barium is going to become the subscript for boron, and the charge of boron is going to become the subscript for barium. You can also, of course, make yourself a plus and minus T chart and work it out that way, and you'll see now that this is a neutral compound. I do the same thing for my other compound. I've got +1 and -1, and we can crisscross those charges or simply recognize that they cancel each other out as is, so we don't have to add any subscripts there. So that was step 2, neutralizing each newly formed compound. Step 3 is going to be to balance the equation, and we've got a lot of practice with that. If you want, you can write out all of your elements down here. At this point, you might be able to balance these equations without doing that. So I scan for an obvious difference in the two sides, and the thing that stands out to me first is I've got 3 bariums on the right and only 1 on the left. So I'm going to try putting a 3 here. I might end up having to change that, and that's fine. I'm going to erase my arrows now. Just clean some of this up. Okay, so if we're keeping track down here, we now have 3 bariums on the left, and we have 3 bariums on the right on the product side. When we put this 3 in here, we also change the number of fluorines. We have 3 times 2 is 6 on the left. So it looks like I'm going to need to put a 6 there as that coefficient, and that's going to give me 6 fluorines on the right. It's also going to give me 6 sodiums, which creates something I've got to fix because I only have 3 on the left. So I'm going to put a 2 in there, and that's going to give me 2 times 3 is 6 sodiums on the left. And let's see where we're at with boron. I have 2 borons on the left, and I've got 2 borons on the right. So we are all balanced. So that's it today. We're going to add some more steps to that tomorrow. Why don't you pause the video and do the U-try problem. Okay, welcome back. Let's go over the solution to the U-try here. So step 1 is to predict your products, and I like to start by labeling the ions here, +2 and -1. And then over here with indium, I've got a +1 charge, and with boron, I've got a -3 charge. So to create my new compounds, I'm going to combine the outer atoms, and that is going to give me strontium boride. Remember, we always list the cation first. I left a little space in there in case we have to add subscripts and coefficients. My other compound, I'm going to combine the inside ions. And again, I'm going to list the cation, which is indium in this case, first. And the anion is iodine. Again, I left a little space there in case I need to add subscripts and coefficients. So notice that I didn't bring the subscripts from the left over. Those don't necessarily come over with the ions because we're going to have, in some cases, different subscripts when they're part of a different compound. So let's look at the charges here and figure out what subscripts we need to use. We've got strontium with a +2 charge here, and we've got boron with a -3 charge. So the -3 charge is going to give me a 3 subscript for strontium using my crisscross shortcut, and the 2 charge of strontium is going to become the subscript for boron. Indium over here has a +1 charge, and iodine has a -1 charge. So those are neutral as is, and I don't need to add any subscripts. So I just completed step 2, which is neutralizing the newly formed compound. And again, you'll notice that the ions on the left and the right do not have the same subscripts. That's oftentimes going to be the case. Last step, I need to balance this equation. Clean things up here first. So I can write out the atoms that I'm working with. Or again, if you don't need to do this anymore, you certainly don't have to. So now I'm going to scan the equation, and I'm going to look for a difference. I'm going to start with strontium. I've got 3 on the right. So I'm going to put a 3 in the coefficient place on the left, and that's going to give me 3 strontiums. Again, it's possible that I might have to change that number as we work through this. That 3 coefficient gives me 6 iodines on the left, 3 times 2. And so I'm going to put a 6 coefficient on the right, which is going to give me 6 iodines. It also gives me 6 indiums on the right. And that means I'm going to need to put a 2 coefficient here because 2 times 3 gives me 6 indiums on the left. And let's take a look at boron. I've got 2 currently on the left because of that coefficient. And because of this subscript on the right, I've also got 2 on that side. So everything is the same. And there is your solution to the U-try. Reach out if you have any questions. Have a great day.